Hi, so I'm Piotr. I'm a senior developer at Monterey, and I'd like to tell you today about worker queues for Node.js and why it might be worth to use in your project. So let's begin, and let's answer a question: what are worker queues and queues exactly, and in general? So let's start with the queue as a data structure. So queues in IT work the same like in a real life queue. So in queue, we can store any data we'd like. And when we add a new data to the queue, we add it to the back of the queue. And when we start reading from the queue, so taking data from the queue, we start from the oldest one, which have been the longest time in the queue. So queues work in a principle like in first in, then first out. And yeah, so that will be the simplest case of the queue, and it can be represented in code with arrays or array-like objects, or maybe preferably with a linked list where you can easily add new elements and pick the oldest elements. Yes, so if we switch to our use case, which will be work queue or commonly also task queue, the items that we store in our queue would be the job description. And then the consumer, which in our case will be the worker, will take that job and then will do something with that information, like perform a task, which should be done with this job. To the queues, those information about the task are produced by the producer, which can be your like main application, your server, or even a worker, which will also add some kind of next jobs to do to the queue. And the main idea behind the queues is to avoid doing a resource-intensive task immediately and just have ability to wait for it until to complete, but give the ability to just like do those tasks in background. So offload the like heavy computing things outside the main server to the different one, and then you can have lots of workers which will just speed up the whole process of doing that heavy task. So we know what's the queue. So why would I need this? When should I use this? So in general, as I just said before, it's good to start with offloading complicated tasks to the different like instances of your application. So you have to do some kind of calculations, then why not? Then you don't have to plug the whole application. So you can easily serve more customers and then just do that logic in a different place. Then if you have some maybe side effects, which like somebody registered in your app, and then you can send those emails not from your main app but from the worker, which can handle lots of more data, and your customer will quickly get a response. Maybe you have like system which is based on events, like user has registered, then you can call some kind of different action, and that different action can cause another action. Then you can easily put all those results into the queue, which can trigger another job. Also, it's a good way if your job, like let's say sending an email, will be able to fail and then automatically could be retried because you keep all the information that are supposed to let the job be finished, right? You know where to send that email and with what content, then you can just retry it multiple times until it succeeds. And also a good example would be if you have lots of things to do, then if you keep that in your app, then your app can crash, or maybe it will perform very slowly because it will try to do all the things at the same time. Then you silo to do the workers, and will be processed one by one, and you have lots of workers, so you only gain with that. So in detail, usage would be great for sending emails, where you can just say like send hundreds of emails, and if you reach the API limit or your API provider fails for some unknown reason, all those emails could be moved to the failed queue, and then just wait and retry at some point, like in an hour. So you don't lose any emails. Your real customers would just get those emails a little bit later than not get it at all. Let's say you have lots of images, like you store the images and then you need to generate a thumbnails or resize them. It's also a great place because that's a heavy thing to do for the computers. So you can just do it one by one, and yeah, don't block the main app. Let's say you have to clean up all data or generate some kind of statistics, and you can do it like, let's say every day at 2 a.m. when there's no traffic, you can schedule things to do and just clean up the data, change some records. If you have like new orders, then maybe update some kind of data in a third-party API. So that's all you can do with queues. And that will be done in the background without slowing down the main application. So we already know what is queue, what is a worker queue, and when I can use it, but there's a still idea, the missing point, where we store all those messages. So we need a piece of code which is called message broker, and there are lots of existing software that can help you with that. And we can use the same software as for the message queues and for the publisher subscriber pattern. And for that, we have applications like an Apache Kafka, RabbitMQ, and maybe less known like Redis has his own implementation, or Postgres, which you can reuse if you already have Redis or Postgres database. But also, if you are using those message brokers, you can use them in multiple languages, multiple frameworks, but it's still a thing that you need to pick the right library to connect to them, and then write your own logic with, like, let's say, retrying a job if it doesn't provide it already, and you have to still maintain them. So you have to do some kind of things to get it working. So what if we had like all-in-one solution that will give you all those things, like retrying jobs, automatically create a queue for you, and so on? So with that answer, there's a Bool message queue for Node.js. And Bool is a Node.js library that implements a fast and robust queue system built on top Redis that helps you resolving many modern age microservices architectures. So what those features are in the Bool that they give you? So we talk that queue is a FIFO, so first in, first out, but sometimes you'd like to reverse that and process the last added item first. Then obviously, BoolMQ gives you this functionality. It's not really common things to do, but sometimes it could be useful, and with just few lines of code, you can do that. Then you can have priorities in your job. So let's say you send 1,000 emails, but you have that one which is in registration confirmation, and it has to go first. Then you can easily put it on the top of the queue, and it will go immediately. Then you have delayed jobs. So maybe you want to send a confirmation just an hour later, and you can easily do that with a Bool, which is a few lines of code. You can schedule and repeat jobs according to cron specification. So you can say at 3 a.m. every day, do something, or maybe just once in a month, do some cleanup. So we can schedule that easily. And the best part is that you can have the job that will automatically retry. So you can say, let's send this email, but if it will fail, then try once again, and once again, and once again. And if it not succeed by then it will be moved to like failed queue, when you can still retry it. And if you, let's say, have thousands of emails to send and your app crashes, if you don't have it in a queue, so in normal application, you store it in a memory, then it will be gone if the app crashes. Now, if you have that in queue, then your app can crash, and then you can just start it once again, and all those emails that should be sent will be resumed from the state where it was left. Yes. So what is the requirement of this BoolMQ to have it in app? We just need a Redis. So probably you already have it. Maybe you are using it as a cache, maybe for some other use, but already is a really fast way to add this, and the setup looks like that. So it's really simple. So all you need to do, if you are a producer, like you want to create a producer, all you need to do is import a queue constructor from the library, and just call it by passing as a queue name as a first argument. You already have a queue at this moment. So what you need to do, you just can create new jobs. And you can do that by using the add function of the queue. And you can pass 3 arguments. First one is job name. Second one is job data. And third one, which we are not using right now, is job options. And what you need to remember that job name and job data will be passed to the worker. And job name and data must contain everything that is required for the job to be complete. So you need to have all the information, otherwise your worker will not be able to complete the job. Obviously, you can connect to the database, but so on, but it needs to be enough to identify what worker has to do. So what will be the setup for the worker? It will be exactly the same, almost exactly the same. Oh, okay. By importing the worker from the library, and then calling new worker constructor and passing the queue name as the first argument. And the second one is the handler. So do we need to pass the function, or reference to a function which will be called for each job that is pulled from the queue. And yeah, in a first argument of this handler, you will get the job information like title and data and some other metadata which you might use. So I'd like to show you now some examples of those advanced features. Let's say it's advanced, but those are really simple. So let's say you'd like to have a job which is delayed for some kind of time. So what you need to do? So basic setup is almost the same as previously, but now you need to also create a queue scheduler. So queue scheduler is a process in the background which will handle the jobs that are delayed, maybe the jobs that have failed and should be moved to a different, let's say, queue or different state of the queue. Yeah, and the queue scheduler, after creating it, importing it from the library and creating a new one with the same name as your queue for which you want to have that queue scheduler, you just create it, and now you're able to set additional options to the job. So as in previous example, we are using add method on the queue. The first argument is once again job name, job data, and now you can use the options in the job. So now we specify the delay that we want. You specify it with the milliseconds. So right now it's 5,000. So the job will be delayed for 5 seconds, and that's it. So no additional code except for creating a simple queue scheduler. What if we'd like to have a retrying job? So it fails, we cannot send the email, please retry. So we do the same idea and use the same simple code. And so we set different job options, and now we're specifying number of attempts. Let's say this job should be retried 3 times, and we can use different setting for backup. So if job fails for the first time, then now the exponential backup will be used. So job will be retried in 1 second, then in 2 seconds, and then another time after 4 seconds. And we can specify it in a linear way or the exponential or other ways to have more control how often should it be retried. Because maybe your email provider will be back in an hour, so you can have like really long retry time. And obviously you can specify it per job setting. So every job can have different settings, but you also can say, my queue will always have the job, like my queue will always have a settings that all the jobs will be retried automatically, so I don't have to pass that. So you can say settings if you're creating a new queue, like in example, and then specify default job options. And those options are exactly the same as for the one job. So you can specify that all jobs added to queue foo will be automatically retried 3 times with the backup, and then just regularly just add a new job to it. Then we have repeatable job. So with cron, we can say the add option repeat and then cron. And let's say the action will be repeated with the cron expression. So this one exactly shows that job should be repeated every day at 3:15 a.m. And so it took us like 3 lines of code. And also we could say like repeat this job, like in this example, 100 times with delay between them of 10 seconds. So sometimes you want to do it that way. And it's really simple. It's just like being giving a command to someone, just repeat, and you are passing the details how it should be repeated. And also you can add priorities to the job. And let's say, yeah, you have 1,000 emails to send and you'd like one mail to be sent faster. So you add priority to this job. And what is worth to mention that adding task with priority comes with a cost, because Bull will automatically check where in this queue there's a job which has lower priority than your new job. So the more things you have waiting in a queue, then the longer it would take to add. But it's not really big deal if you don't do that really often. But it can save your life sometimes. So yeah, the highest priority in this case would be 1, which we specify in an options, and the lowest priority is max int. So everything with smaller value has higher priority. And yeah, and that's it. You just add a priority option. And obviously you can mix all those settings. So you can have priority, and then job can be delayed and job can be retried. So you just mix all those parameters. And yeah, this is really simple API for doing it. And let's imagine that you have the queues for running for a while, let's say a couple of hours, and then you'd like to see, okay, so what's the status? How many jobs are still waiting? How many of those failed and why they failed? So with help, there are bull dashboards. So UIs which you can view from the browser, and first two from the list, Arena and Bullboard, are free, so you can just download them from through the npm and just use them. And the third one is the task force. Is from creators of the Bull. They claim it's the best one. Haven't been using really because those two give enough data for me. So what features such dashboard give you? So obviously you can check the queue health. So you can view how many tasks are pending, waiting, finished, or failed. You can preview the job contents and the job list. So you can view that, let's say, JSON you sent to the job. So you can know what will happen if those actions will be completed. You can trigger new job from the UI. You can pause the whole queue if you know that, like, your mail provider will not work for next hour. So don't even try to send that, and you can just unpause it later. But still, queue will get new jobs. You can view the job progress, and yeah, obviously you can check the logs, number of retries, some kind of dates when it started, when it's finished. So it gives you lots of information with just a few lines of code, as I will show you later. Yeah, so now I'd like to switch to the code and show you how you can set up the simple app and simple use case of worker queues. Okay, so I prepared a simple app which consists of, maybe I would make it a bit bigger, even more. Yeah, so I prepared a small example, which app in TypeScript, which has server and worker and some utility files. So this app is running Express.js as a server, which we'll be using to host the UIs. And what's here? So I imported all the required things for us to run the bull. I have Redis running in the background, and I'm specifying custom options for connection to the Redis. So localhost will be used as host, and port will be 50/50 because that's what I just set up. So we're now initiating those queues. So I created just object for a convenience. Added is a new queue, and I'm calling queue constructor. And then I'm passing the queue name. And in a queue options, I'm just passing a custom connection for Redis. I'm also creating queue scheduler at the same time with the queue name and the same queue options, connection options to Redis, because those are custom one. As you can see, schedulers isn't used. You just create queue scheduler and it will work instantly in background. So no need to do anything with that. I also created utility functions for me. So because it's TypeScript, so I made sure that if I'm adding my function, utility function that will add jobs to the queue, I'm making sure that I'm using the jobs and the job schema that will be the same always. So I'm not missing any data that workers might need to perform this action. So I can show you that so my worker job type is a union type of those all three types, and those types have in common that they have type and the data properties. And so TypeScript now, when adding the job, will know, because I give it a type like this, like print hello world, so we'll expect the same data every time. Yeah, and that will be it. Now it's just 3 post endpoints which will trigger some kind of actions. So in this case is a post endpoint hello world, which will trigger action to just print hello world. Second one is heavy computing. This job will block worker for a while, so we could see what will happen. And the third one is a retriable job. So this job may fail or not, so we just map random possibility whether it will fail or not. And that's it. And now we'll be able almost to use. So I will show you how the worker looks. So the idea is the same. I import the worker from the bool MQ. Then I create a new instance of worker. And I pass the same name of queue that I'm using in my server. And now the worker options is just the connection to the Redis because it's not default one. And I'm passing the worker handler. In worker handler, it's a function which accepts the job. And I also use the types. So I use the same worker job, so I know exactly what will come to the from the queue if we are reading it. So I'm type safe here, and I just do a simple switch based on the type that I use in a worker. Obviously, it could be more sophisticated, like switch between like the type and then just call the use cases, which will do much more things. But for the simplicity, I just console log some data so we know that this job triggered correctly. And if you will have something more, then it would be a good idea to just extract all the code into like some kind of use case like here. And what's also a thing that I said that you can preview the progress of the job. So you can just do job that update progress and then say from 1 to 100% how much the job was finished. And the last job type is fail or not, so it will automatically fail. And I just like to show you that it will be automatically retried. Okay, so let me start the application. So we start our server. Okay, size it a bit. Okay, so as you can see, server is already up, and yeah, streaming. Okay, and worker also started. It should be much faster, but now I'm just streaming. And so I can switch to the HTTP client, and with those requests, I will trigger the job. So for example, I just trigger the hello world. And as you can see, instantly after the request is finished, the server passes the information to the queue and is instantly being read by the worker. So it almost instantly if there's nothing going on. But if you trigger some kind of job which is like blocking your worker for a while, like the heavy computing job, you can see it started the job, and in after 5 seconds, it should be completed. So if we trigger this job and then we try to print some hello words, as you can see, nothing will happen because the job is processed one by one. So after that, those jobs are quickly being resolved. And the same would happen, maybe not the same, but it will, yeah. If you trigger this job that could fail, in my example, okay, I just triggered it once, and you can see it failed, but then automatically it was retried and it completed after 1 second. But we have jobs that will fail more than once, then the delay between another tries will be longer. So yes, so we can trigger many retriable jobs and have some hello words, and it will be automatically like retriable job doesn't block the whole worker. And yeah, so that's the basic example of how it looks, but I'd like to also show you how the dashboard looks and what features they give. So this is the Bull Arena. Maybe I will zoom a bit. Okay, which is really simple, built on Bootstrap. And as we, okay, yeah, as I just configured it, and we have just a single test queue. And I forgot to show you how to configure those. So let me switch back to a server to not miss anything. So as we have the Express server, which is listening, so if you'd like to add Arena, you just only import the Arena from the library. And all you have to do, as with the bull, just say it's going to be a bull queue, and then pass the queues you'd like to have in a UI. So I'm using my queue name and calling it a server, and then passing Redis options. And I'm all set. All you have to do is to expose this URL with the middleware, and then I can just also show you how the second dashboard bullboard works. So yeah, almost the same setup. So I include all the required code. I'm saying that I'll be using the Express adapter, and I'm creating a new bullboard and passing which queue would be used. So I'm calling them bull and queue adapter and passing my queue from the queues object, and then setting the base path and exposing it with the URL to the Express. So setup is also like 5 lines of code, and you have all those dashboards. And going back to it, so this is the Bull Arena dashboard, which is pretty simple. But if you go to your queue, you will have list of jobs split it into types like waiting, active, completed, failed, delayed, paused, and waiting children. So we can go into completed list and see all the jobs that have completed. If we open one job, You can remove this from the history. You can trigger it once again. You have the state, you have the timestamps when it was processed, triggered, and so on, how many attempts there were. You can link it to the another person or see what the data was sent. So you have lots of data here. And if your job fails, it's in a different state. It's like a failed. And then you can see why it failed, because you will get reason for failure and how many attempts. So it's really nice way of diagnostic why some kind of actions failed, and it all will be kept for you if you'd like to, because you can obviously turn that off and those will be deleted after failure or success. And yeah, this is the second dashboard, which is a bull dashboard, bullboard exactly. So this one is a bit nicer and also has additional feature that all the changes are visible in real time. So after I will trigger some jobs, it will automatically change the status, so you don't have to refresh the browser every time. You have the latest, so you can view. And what is cool about the bull dashboard is gives you like nice tag traces with even some syntax highlighting, so you exactly know where this happened, why it failed, and when it failed. And you can technically like retry all those fails. So you know that, okay, my mails haven't been going out, but now I can retry them, and click just retry, and those will be moved to the active tab, or to waiting tab, or once again to fail tab, because all those 27 that were here just have been processed. And I can trigger some more too, so you will see that, let's say, delay tab will change. So I'll trigger some heavy computing. Oh, maybe not those. And some retriable requests. And now the UI should refresh at least. Yeah. So we have the waiting jobs that will quickly go out. Yeah, so you can preview the state and check which jobs are waiting, which jobs are going on. So it's really nice way to diagnose your app and see whether you need more workers and so on. Okay, so I think that's a short overview. So I recommend you the Bull if you haven't used workers already. It's a really nice way to start, and obviously has some drawbacks. Yeah, but for start, it's really, really great tool. Yeah.